Okay, yesterday we practiced question from electromagnetism, left-hand rule, DC motor, and we find that there are like very few questions, limited questions related to the left-hand rule and the DC motor. And today we will solve questions related to electromagnetic induction. And the concept of electromagnetic induction is like in simple words, we have to generate electricity, right? We provide electric current to electric motor, so electric motor starts to rotate. So now we have to apply reverse process. Like we have to apply force by ourselves. Like if we are able to rotate the propeller or the turbine or the fan of the motor, so it starts to generate electricity. So this is the concept of electromagnetic induction and why we use the word induction because there is no physical connection this time. Like in these diagrams, you can see there is no electric source or no battery, no electric AC DC source we are using. If we move magnet into the coil, right? So when magnet moves into the coil or out of the coil, so during the motion of the magnet, magnetic field lines change. And when magnetic field lines change and it cuts the coil, so it will generate an induced EMF, right? So the word induced is like there is no physical contact between them, just like in previous DC motor, there is direct contact of electric current. And we know that current moves, it produces magnetic field due to this magnetic field. There is a force on the coil, but this time there is no physical connection with the wires, but we just move magnet in or out of the coil or through the coil. So due to change in the magnetic field lines through the coil, voltmeter shows reading. You can see in this one, when magnet is at rest, so there is no reading in voltmeter, no deflection. But when magnet starts to move into the coil, so it shows deflection. It means we are getting the value of EMF or electric current in the coil. So that's why it is called induced. Induced means change or like we can say change in the circuit or change in the motion of the voltmeter or deflection in the coil of the voltmeter due to the change in the magnetic field lines. So one change happens due to the change in another category in another quantity. So due to change in the magnetic field lines, an EMF induce or electric current induce. So this is the concept of electromagnetic induction. And let's suppose if we move this magnet very fast or if we move this magnet slow, so these are the factors. If we increase the number of turns, so increasing the number of turns will also increase the reading in voltmeter, like increase in the value of induced EMF. If we are using a stronger magnet, so stronger magnet will also increase the value in the output. So if we move at high speed, so moving magnet at high speed will also increase the value in voltmeter. So these all are the factors that will affect the value of induced EMF. And what actually happens, magnetic field lines interacting with the coil. In short, we can say magnetic flux linkage. Magnetic flux linkage means number of magnetic field lines passing through area of a coil is called magnetic flux linkage. Flux means number of lines of magnetic field passing. Linkage means that is linked with the coil. So when there is a change in the number of magnetic field lines through a coil, so an EMF induce. And this concept is called electromagnetic induction. And today we are going to discuss about this phenomena and all the questions related to this. And same on the same process, AC generator works when we move like magnet through the coil, or we just consider the concept of AC generator. So in AC generator, we have all the same setup. There is only one difference. We are using slip rings. This time we have two rings, separate rings, right? You can see in the diagram. This ring is completely separated from the other one. So from one ring, current moves in one direction, like from this side or the from first ring, current moves from left to right. And from the second ring, current moves from right to left. So half of the cycle current moves from right to left, and other half cycle current moves from left to right. So there is continuous change in the direction of electric current, and when there is continuous change in direction of electric current, so that is called AC, alternating current. So now let's see how the questions are linked with this concept. In this question, it shows a single turn coil. So there is only one turn in a coil, and it is DC motor right now. And current is moving in this direction. So the concept in the first question they ask is explain the direction of turning effect as seen by an observer at O. So basically observer is over here, and from this side we are observing the direction of rotation, and we have to identify what is the direction of rotation. So it is very simple. Again, current is moving into the paper from left hand side. It is coming out of the paper from the other side. So just like yesterday we practiced questions for the DC, we have to apply the same idea by using left hand rule. So in first part we have to use left hand rule because this is DC, right? This is not AC. In AC we have to use a right hand rule, but this is DC, so we have to use left hand rule. So according to the left hand rule, magnetic field is moving from right to left. Magnetic field is moving from right to left, and current is like outward or inward. It's up to you. If we choose left hand side, so magnetic field is moving from north to south, from right to left. Current is moving into the paper. So force applied on the coil on the left hand side will be upward, and force on the other side will be applied in downward direction. So it will rotate like this. From left hand side, it will rotate in upward direction. From right hand side, it moves in downward direction. So there is clockwise rotation. So explanation of this question is coil rotates in clockwise direction. Force on left side of the coil is acting in upward direction. And on right side, force acts in downward direction.
Sir, if it would be AC, would it be counterclockwise?
If it is AC, so it will rotate in both direction, half of the cycle clock, half of the cycle, because in AC we have to rotate by ourselves. So it depends upon you in which direction you are going to rotate, right? They will ask question about AC also. We will get those questions also because this is like linked with DC. Because in right hand rule, let me show you that part. In right hand rule, the direction of induced EMF is not given. In right hand rule, you can see induced current is unknown. Direction of applied force and magnetic field always given. It's up to you in which direction you want to rotate, because you have to rotate, you have to do kinetic mechanical work done so that you will get induced current or induced EMF. So it depends upon you, right?
Yeah.
In second part, the coil is replaced by an otherwise identical new coil. So now we replace this coil and we have new identical, like same type of coil, identical, but this time we have three turns. In the first coil, we have only one turn and same current. So when there is same current in the coil and same material we are using, so how the turning effect compares with the turning effect in part one. So you can see all the things are same, but this time we are using three turns of the coil. So there are three turns, and we know that if we increase the number of turns, so that will also increase. You can see, to increase the value of force, use a stronger magnet, more current in wire, use a longer wire, or more turns in a coil. So if we are using more turns in a coil, so that will increase the value of force. It means the rotation will be increased as compared to the first part, right? So definitely turning effect will be greater. So there will be greater turning effect. Now we have third coil. Third coil is also identical to coil in part 1, like single turn coil, but its resistance is 3 times greater and potential difference is same. So potential difference is same just like in part 1, but resistance is 3 times greater as compared to the part 1. Now, how the turning effect compares with the turning effect in part 1. So basically, potential difference is same, but resistance is 3 times greater. So resistance of the third coil is greater than resistance of the first coil. It means when you increase resistance, so current decreases. So it means the current of third coil is less than the current of first coil. And definitely when we decrease the value of current, so it is mentioned more current will give you more force. Less current will give you less force. So we decrease the value of current by increasing the resistance. So it means you will get less turning effect as compared to the first coil. Because current is decreasing. So these are all the parts linked with DC. Now we have a question of AC. Figure 8.2 is a voltage time graph showing the output of a simple alternating current generator at time T0, T1, T2, and T3. And in figure 8.3, it is an end view of the plane of the coil of the generator at time T is equals to T0. And coil is rotating clockwise. Now you can see rotation is given, right? Because now we are talking about AC. It means we have to use Right hand rule this time, not left hand. So that's why rotation is already mentioned clockwise, because in this current is not given. Value of induced current is unknown. So this is the coil, right? Like initially the coil is in this position. We have point A on top, point B in bottom, and this is the axis of rotation. And around this point, this AB starts to rotate. And they mention at time t is equals to 0. This is time t is equals to 0. And at this point, axis of rotation is given. Draw and end view of the position of the plane of the coil at time t is equals to 1. Now you have to draw end view of the position of the plane of the coil when time is equals to t1. So just like this diagram, you have to also draw another diagram, but this time we have to use t1. So let's suppose uh, at time t is equals to 0, like t naught, we have minimum voltage, right? Because you can see it is completely equals to 0. So we have minimum voltage. Minimum voltage means perpendicular position, because we know in perpendicular position, we got minimum value. And in the next cycle, you will get maximum rotation, right? So it means that rotation is given clockwise. So this will rotate clockwise 90 degree. So after half rotation, it converts into horizontal one, and you will get maximum voltage. Maximum voltage means position will be horizontal. So you have to rotate this AB, right? Like if you rotate this one, so now you can see AB is rotated. And if you further rotate it to 90 degree, so you will get this position, right? If we further rotate 90 degree, we will get this position, right? Further rotate 90 degree, you will get initial position, right? So this is the idea mentioned in this diagram also. You can see initially we have vertical 0, then we rotate 90 degree, horizontal position, we got maximum forward current. Then again we rotate it to perpendicular, so it becomes again 0. Again after 90 degree rotation, you got horizontal maximum, but direction is opposite, right? Any confusion in this point? So in every horizontal position, you will get maximum voltage, but you have to check direction also, because we are starting from vertical position. This is vertical position, AB. So after rotation, you will get horizontal position like this, AB. Then again at this point, you will get perpendicular position, but sides will be reverse. So I will mark all the positions so it will be easy for you to understand like this. First of all, we have perpendicular. Then we have 90 degree change horizontal. Then again perpendicular. Then again horizontal. Again perpendicular. Again horizontal. Again perpendicular. Okay, so we started from vertical position. This is point A. This is point B. And after clockwise rotation, we got point A over here and B over here. Then after further more rotation, we got point A over here, B over here. After further rotation, we got point A over here, B over here. Now again after rotation, we again got same position A, B, and it will continue, right? So this is the idea of AC. Simple. Now, basically, according to the question, which position is the answer for the first part? So they are asking about T1. So in T1, we have maximum voltage. So this is time T naught. This is time T1. And then we have this point, again perpendicular, again horizontal, again perpendicular. So after this, we have again perpendicular, horizontal, again perpendicular. This is time T2. Because you can see this is the same position, just like the first one. And then we have T3. T3 is horizontal, perpendicular, horizontal. Horizontal, perpendicular, one more horizontal. So this is point T3. So basically in the first part, they are asking about this specific diagram. So this is the answer, right? For the first part. All other diagrams are just for the explanation for your reference. The answer is the horizontal one that you have to draw. In next part, again, they are asking the same, draw an end view of the position of plane of the coil at T2. So we already draw all the positions. So at T2, you can see this is the answer. This is the answer for T2. Because we mark all the position, so it will be helpful for you to identify every position from the graph and also to draw the diagram according to the given position. Okay, so this is the answer, yes. And in last again, they are asking about T3. So T3 is again the last position. This one, A on the left, B on the right. So this is the answer of third part. So this is one question from AC. Let's find other one. Okay, question number 8 is related to transformers. Basically, in transformers is used to like convert voltage from high to low or low to high. If you want to increase the voltage, so that increase in voltage is called step up transformer, and when we decrease the voltage, so that is called step down transformer. So let's see what is the question is. So in question, the electricity supplied to a town is transmitted using a high voltage cable, because we know that we are getting electricity in our town, and that electricity is generated from like any source of power plant or electricity power plant station. So in electricity power plant station, we know that there is very high voltage. And it is mentioned the electricity supplied to a town is transmitted using a high voltage cable. Just like if you travel through like another city, so you find that in the path we find a very huge towers of electricity. So electricity is actually transferring from the wires through the cables of that huge towers. And a transformer in the town has a soft iron core. The meaning of the soft iron core is just like yesterday we discussed, iron can be easily magnetized and easily demagnetized. So the question is explain the principle of operation of a simple iron core transformer. So we will explain whole idea that what actually happens. So basically, let's suppose if we have two categories. First category is step up. Second is step down. So basically what happens in step up, if we have one coil connected with the source, AC supply. So second coil connected to the output voltage. So current starts to flow from one coil, and it will generate magnetic field around it. Right? So magnetic field generates around it, and due to the change in the magnetic field, magnetic flux linkage, an EMF induced in the second coil, just like electromagnetic induction. But there is one difference. You can see the number of turns of this coil is called primary, and the second coil is called secondary. So in primary coil, we have less number of turns, and in secondary coil, we have greater number of turns. So when we have less number of turns, so you will get less voltage, and when you have greater number of turns, you will get high voltage. So that's why it is called step up transformer, because it converts the voltage into high, and step down works in the opposite. Like in the primary coil, you will get less number of turns, sorry, greater number of turns, like this. This time we have greater number of turns. In secondary coil, we got less number of turns. So when we got less number of turns in secondary coil this time, so there will be less voltage, and we have greater number of turns in primary coil, so there will be high voltage. So basically, when electricity transfers from the main power plant, so it consists of high voltage. That's why in question it is mentioned, the cable consists of high voltage. And when it transfers to the town, so in town we know that we are using 220 to 30 volt in our houses, but in transmission cables, there are thousands of volt transferring. So basically, we use a step down transformer in our town that converts high voltage into the low voltage. So this is the idea. So according to this idea, we have to explain the principle of operation. So principle of operation is very simple. We use alternating current pass through primary coil.
Could you explain this again, please? I didn't quite understand it.
Step down.
Step up and step down.
Basically, in a step up and a step down, there is like a game of number of turns. So you observe that in a step up transformer, there are less number of turns in primary coil as compared to the number of turns in secondary coil, right? So we have more number of turns in step up. So when current, AC current or alternating current passes through the primary coil in a step up transformer, so it generates magnetic field just like electromagnetic induction. And due to change in the magnetic field lines, an EMF induced in the secondary coil, but we will get high value of induced EMF. High value of induced EMF in the sense because there are more number of turns. Because number of turns increases the value of induced EMF. Just like in DC motor we discuss, if we increase number of turns, so the value of the force also increases. So when we increase number of turns in any coil, so for that coil, the value of induced EMF also increases. So in a step up, we provide like the value in the primary coil, like in input is less and the value in output will be greater because we have more number of turns in coil. So due to change in the magnetic field lines, a large value of EMF induced in the secondary coil. Then we have a step down transformer. And in a step down transformer, we have reverse formula. Like again, we connect AC supply, and that AC supply is connected with the primary coil. And again, in primary coil, we have large number of turns, like greater number of turns in primary coil. So again, more number of turns, more EMF. But in secondary coil, we got less number of turns. And when we got less number of turns, so definitely you will get less voltage in the output, right? So if you want to increase EMF in output, so increase number of turns. If you want to decrease EMF in output, decrease number of turns, right? So this is the idea. I also explain whole concept over here. First of all, alternating current pass through the primary coil. Either it is a step up, either it is a step down. We are not talking about that. So basically, alternating current pass through the primary coil, and when current passes through the primary coil, so it produces change in magnetic field. So current in primary coil generates changing magnetic field in it. Like in primary coil, magnetic field produces, and we are using soft iron core because soft iron core is the piece of iron on which we use to wound that wire, right? So when we use that wire to wound on the soft iron core, so it can be easily magnetized, easily demagnetized. So this iron core transfers magnetic field to the secondary coil. So from primary coil, these magnetic field lines transfers to the secondary coil with the help of soft iron core because soft iron it can be easily magnetized and easily demagnetized. So it helps to transfer the magnetic field lines through long distance and it can easily interact with the secondary coil. And due to change in the magnetic field lines, EMF induced in the secondary coil. Due to change in magnetic flux linkage and EMF induced in the secondary coil. So this is the idea of, and this is the principle of working of transformer, right? Either it is a step up, a step down, it works like the same. A step up, a step down only tells you about the number or like the value of EMF induced in the coil. And let's suppose if we talk about the number of turns in B part, the transformer steps the supply voltage down. So we are using a step down and you can see the initial value is highest like 220,000 volt and it decreases to 33,000 volt. So initial voltage is high and final voltage is less. So we are using step down transformer, voltage is decreasing. So this is the voltage of primary coil because in primary coil we have large number of turns, but in secondary coil we are having less number of turns. This is a step down, step down. So in primary we have large number of turns, high voltage, greater number of turns. And in secondary, we are getting less voltage because we have less number of turns. And it is also mentioned there are 450 turns on the secondary coil. So this is the number of turns in secondary coil. And we have to find out the number of turns on the primary coil. So number of turns in primary coil is unknown. Voltage in primary coil is given. So now we have to compare their quantities to find out the answer. So this is very simple. We have to use this idea. The number of turns in primary coil will gives you the idea of voltage in primary coil divided by number of turns in secondary coil is equals to the voltage provided by the secondary coil. Okay. Because if you increase the number of turns in primary, so voltage in primary also increases. And if you increase the number of turns in secondary, so voltage also increases. So this is the relation between number of turns and the voltage. So NP is unknown. This formula will look like Vp into Ns divided by Vs. So NP is equals to,
Says this 3,000 number of turns.
right, good. So now it's just a calculation. So you can see number of turns in primary is 3000. Number of turns in secondary is only 450. So now you can see when voltage decreases, so number of turns also decreases, right? In the next part, we have to find out the value of current. This is also simple. The electrical power transferred to the transformer by high voltage cable is 77 megawatt. This is mega 10 to the power 6, positive 6. And calculate the current in primary coil. It means we have to find out current in primary coil and electrical power by high voltage. So power is given. Okay. So basically from the formula of power, we know that P is equals to VI. So power is given, right? Power is 77 exponent 6. Current is unknown. And we already know about the voltage. So it means power in primary coil is equals to voltage in primary coil into current in primary coil. So current in primary coil is equals to, this is the simple formula of the power we use in electricity. So power is 77, mega means 10 to the power 6 divided by voltage in the primary. Voltage in the primary is 220,000. This is the value of the voltage. So now you can just simply divide them to find out your answer.
$350.
Okay. So you are getting answer 350, right? So in this way, you can calculate the value of electric current. So in this way, you can find out the unknown quantities using the transformer. This is also based on electromagnetic induction. Okay. This part we left yesterday because it is also related to transformer. Now you can also solve this part. So electrical power is transmitted at a voltage of 400 kilowatt. So power is given. A transformer reduces the voltage, right? Reduces means again it is a step down, right? Because it is reducing, reducing means step down. The voltage to 33 kilovolt. So this is primary, this is secondary. Because initially we have 400, we reduce to 33, that will become secondary. For use by heavy industry in large factory, okay, the number of turns on the primary coil of the transformer is 11,000. This is the number of turns in primary. Calculate the number of turns on the secondary coil of the transformer. So we have to find out the number of turns in secondary coil of the transformer. So again, this is simple question, right? You know, N is given, P is given. So we have to relate with number of turns and with the power to find out the answer. So it will be like number of turns in primary is equals to divided by number of turns in secondary divided by voltage in secondary. So number of turns in secondary is unknown. So number of secondary turns. So number of secondary turns will be equals to, okay, this is voltage because it is mentioned kilovolt primary and this is secondary. So NS is equals to NP means number of turns in primary multiply by voltage 33,000 divided by voltage in primary is 400,000. So again, you just need to multiply. You will get your answer. How many number of turns are there in secondary? Nine hundred ten, right? So in this way, we can calculate a number of turns or voltage in the transformer with the help of the concept of the transformer. Magnetic field, electric current. Now you can see there is one more question related to transformer. Okay, let's consider this question. Figure 9.1 shows a magnet on the end of a spring and a coil of wire connected to a sensitive zero galvanometer. So it shows a magnet on the end of a spring and a coil of wire connected to a sensitive galvanometer. Galvanometer also measures the value of electric current. So magnet can move freely through the coil. Now a magnet is pulled down and released. So in the diagram, you can see there is a spring connected with the magnet. So if you just pull that magnet and then release it, so it starts to oscillate like an oscillating body up and down. So magnet starts to oscillate up and down. And definitely when it starts to oscillate up and down, so it continuously changes the magnetic field line through the coil. And when there is a change in the magnetic field line through the coil, so this needle of the galvanometer also deflects to and fro because this magnet also starts to move up and down. And the question is, describe and explain what happens to the needle of the sensitive galvanometer. So we detect that there is a change in the magnetic field line, so it will also cause the change in the direction of the needle. So basically, magnet oscillates in up and down direction. Therefore, needle oscillates back and forth. And why it happens? Because magnetic field lines cuts the coil and changing direction continuously, induced EMF or induced current also opposes the motion of the magnet that cause this change. So this is again the same phenomena of electromagnetic induction. We know that magnet moves out, moves in. So due to change in the magnetic field lines, it will induce EMF, but it is like freely moving magnet because of the spring. So due to this spring, magnet oscillates up and down freely in any direction, like in upward and downward direction. So coil or the needle also deflects towards left or towards right continuously with the change in the direction of magnet. Now, the magnet is replaced with a stronger magnet. State the effect of using a stronger magnet on what happens to the needle of the galvanometer. So if we use a stronger magnet, so definitely you will get maximum deflection or larger deflection as compared to the previous situation. So we will get maximum deflection as compared to the previous one. And again, we have a question of transformer. This is the third question of transformer we are getting. So there is a step-up transformer used to step up the voltage of a power station from 25,000 volts to 400,000 volt for transmission along power lines. The number of turns on the secondary coil. So this is the number of turns in secondary coil, 36,000. And again, you have to calculate the number of turns in primary coil, which is unknown. Again, same formula. And VP NS over VS. NP is equals to, this is primary voltage, this is secondary voltage, because this time we are using a step-up transformer. 25,000 multiplied by 36,000 divided by 400,000. So 25 into 360 divided by 40 is equals to 2,300 number of turns in primary coil. Question number 10. A transformer has 500 turns on the primary coil. So again, we have transformer with number of turns. The number of turns in primary is equals to 500. Number of turns in secondary is 25. The input voltage is 120 volt. Calculate the output voltage. So same formula. Output voltage means This is the voltage of primary, and this is the voltage of secondary. So number of turns in secondary coil is 25. Voltage of primary is 120. Number of turns in primary is equals to 500. 6 volt is the voltage in the output like in the secondary coil. Now the current in primary coil is 125 milliampere. Transformer is 100% efficient. It means input is equals to the output. Calculate the output current. It means current in the secondary coil. So according to the concept of the power, because transformer is 100% efficient, so power of primary coil is equals to the power of secondary coil. It means Vp Ip is equals to Vs Is, because power is equals to voltage into current. So primary uh, voltage current is equals to secondary voltage current. We have to find out the value of Is. Is is equals to Vp Ip over Vs. So voltage in primary is 120. Current in the primary is 125 milliampere minus 3 divided by voltage in secondary 6. So 0.125 multiplied by 120 divided by 6 is equals to 2.5 ampere. In part B, figure 10.1 shows a loose wire connected in a circuit with a DC current and a switch. The length of the wire between the two supports is in the magnetic field of a horseshoe magnet. So there is a magnetic field of a magnet in which this wire is hanging freely, and the power supply is switched on and wire moves down. So it is like from the concept of the Fleming's left hand rule, when current passes through the conductor, so it exerts force in upward or downward direction. So basically force acts in downward direction, it moves down. Now on figure 10.1, draw an arrow on the wire to show the direction of current. So let's draw an arrow to show the direction of current. So basically, magnetic field is moving into the paper. Field is into the paper because that is like in the depth of the paper. So it means it is moving into the paper. So either current will move from right to left or left to right because force is acting in downward direction. Force is in y-axis, field is on z-axis. So you have to place your first finger into the paper, and for thumb is like in downward direction, right? So first finger into the paper and thumb is in downward direction. So your second finger will points in this direction. So it means current moves from right to left, right? So now you can arrange your left hand rule. First, open up the first finger and that is towards the screen and thumb is in downward direction and second finger is towards left hand side. So current is moving from right to left. Now the power supply is switched off and wire returns to its original position. The power supply is then switched on so that the current is in the opposite direction. So basically now current is moving in opposite direction. Now current is moving from left to right. This time left to right. Initially it is right to left, but now it is left to right. State and explain what happens to the wire. So basically this time wire moves upward because in this condition force is moving in downward direction. So when we reverse the direction of current, so it will be yes, wire moves up as direction of force in wire is reversed, right? The wires move up, so reversing the direction of current will also reverse the direction of force. And a split ring commutator is an important feature of DC motor. It suggests one reason why DC motor cannot operate without a split ring commutator. So we know that when coil rotates from horizontal to vertical position, so it is stuck over there. So it will not continue its motion further. So that's why we have to make a break in the commutator. So it will help to rotate half of the cycle due to inertia. So if there is no gap, there is no cut in commutator or there is no split ring in the DC motor, so coil rotate in the same direction. So this is the same idea from the DC motor. So these are some questions from electromagnetic induction also. Mostly in new papers, we found that questions are from transformers and electricity. Like this is also from, I think, 21. Yes, 21. So in 21, 22, 23, in these 3 years, we got many questions from electricity. Majority are from electricity. Then on second number, we got mostly questions from transformer. There are like 4 to 5 questions. In these 3 years, we got consecutively. So transformers, we got more questions from it, and electricity, we got more questions. And then we got questions mixed, like question from AC and DC. So maybe like in this year or like in this May June 24, maybe we will got like more questions from AC or DC, because in previous 3 years we got less questions from AC and DC. So it is just like a chance. Maybe they will repeat the same pattern. This year you will also get the same question from transformer again. So, but from the pattern, we are just counting the number of the questions from the concepts. So it is easy like to solve electromagnetism and electricity new paper patterns like from 21, 22, 23 we solved. And further we will go towards like old paper like 18, 19 also to check what is the pattern in those papers also. So and tomorrow inshallah we will practice questions from nuclear section, because that is the last section that we have to practice. And for space physics, we will continue that past paper questions of space physics in our regular class on Thursday or Friday. So in this way, we will complete all the theoretical questions practice in this week. And from Sunday or Monday, we will start ATP section.